Hey, welcome to Next Gen Manufacturing. Today we're going to dive into something pretty fundamental, a shift in how we build our most advanced machines that's, well, it's almost invisible. And it all kicks off with a really simple question.
So yeah, really think about it. When you picture one of those jets just blasting through the sky, what do you think is holding it all together under those insane forces? You might have an idea, but I'm willing to bet the real answer is going to surprise you.
Okay, so for ages, the answer was pretty simple. Rivets. Thousands and thousands of them. But check this out. Today, on our most advanced aircraft, the most critical joints, they're not held together by any mechanical fasteners. Nope, they're held together by glue. Yeah, you heard that right. Glue. Okay, highly advanced structural adhesives, but still, these are stronger, lighter, and way more durable than a metal rivet could ever hope to be. Now, obviously, we're not talking about the stuff you'd find in a craft store, right? This is serious business. It's called structural bonding. And it's a technology that was born in the super high-stakes world of aerospace, where literally every single gram counts and every point of stress could be the difference. And what's wild is how this tech has quietly started to show up all around us.
Now here's the thing, this isn't some flash-in-the-pan brand new idea. Just look at this timeline. This has been a quiet revolution building for decades. It kicked off with military aircraft back in the 70s, then it moved over to passenger planes in the 80s. And the first big break in the car world? That was the 1984 Renault Espace. So yeah, this has been a slow, steady takeover.
All right, so to really get a grip on this technology, we got to go back to where it all started, aerospace. I mean, it makes sense, right? The insane demands of flight, needing maximum strength, but with the absolute minimum weight, that was the perfect pressure cooker for this kind of innovation.
See, the old way of doing things with rivets had this one massive, fundamental flaw, especially when you start working with modern materials like carbon fiber. Every single hole you drill, well, that becomes a weak point. It's a spot where stress can build up and, where a catastrophic failure could start.
And the source material really puts it bluntly. It says that composites are just sensitive to holes. The very act of drilling into them causes this huge drop in the resistance. Think about that. You're literally making the material weaker just by trying to hold it together. It's a complete contradiction.
And this is where bonding just completely changes the game. Instead of focusing all that stress on a bunch of individual rivets, an adhesive spreads the load out across the entire surface. No holes means no manufactured weak points. Simple as that. Plus, it's lighter, and it's even better at handling vibrations and resisting that constant flexing that can lead to metal fatigue. It's a win-win-win.
This whole new way of thinking about construction led to incredible things like the sandwich panel. And this concept is just genius. You take two super strong but really thin skins, think carbon fiber, and you bond them to this thick but incredibly lightweight honeycomb core. What you get is a single part that is unbelievably strong and rigid, but it weighs next to nothing compared to a solid piece of metal. But yeah, making these things is no joke. It's a serious high-tech process. The parts are bonded, and then they're cured in these massive, high-pressure ovens called autoclaves. We're talking temperatures rocketing up to 180 degrees Celsius and pressures that are 7 times what we're feeling right now. All of that just to create one perfect, seamless bond. So aerospace proved it could be done. Awesome. But now comes the really big challenge. How in the world do you take a technology that needs these giant ovens and hours of curing time and make it work on a lightning-fast car assembly line? Yeah, this table just lays it out perfectly. It shows you the huge shift in priorities. In aerospace, weight is everything, and if it costs a lot, well, performance justifies it. But in the auto industry, cost is king. You have to get that price down. An airplane part can bake for hours. A car part has to be solid and ready to go in minutes, if not seconds.
And you know what? This massive change in priorities forced this just incredible wave of innovation. Engineers basically had to figure out how to get all those amazing benefits from aerospace bonding, but do it on a factory floor, at full speed, and without breaking the bank.
And they did it. Here's the magic. Instead of a giant oven, they came up with something called flash curing. So a robot applies the adhesive with insane precision, then the parts are clamped together, and then, and this is the cool part, a high-frequency field, kind of like a super-focused industrial-strength microwave, zaps it. And that cures the bond in as little as 30 seconds. Boom! The part is solid, ready for the next station. And get this new process wasn't just way faster, it was also unbelievably more efficient. I mean, look at these numbers. The data shows that running a traditional hot air oven for this kind of job cost about 150 euros a day in energy. The new high-frequency system? 10 euros. Just 10. That is a staggering 93% drop in energy costs. That's a game changer.
And from there, this tech just took off. Bus manufacturers started using it to bond on lightweight roof panels. Why? Because that lowers the vehicle's center of gravity, which makes it way more stable. In the world of trains, it lets them build these lightweight metro doors that can open and close super fast. And even heavy-duty locomotive cabins are now put together with these rigid adhesives for way better shock resistance.
So when you kind of step back and look at the whole journey, from fighter jets to family cars to the train you might take to work, it's pretty clear this is a fundamental change. It's a whole new way of thinking about how we put things together.
Right, so this is so much more than just a new type of glue. It's not just a simple replacement for a rivet or a bolt. It's really a key that unlocks completely new ways of designing and building things that, honestly, we could only dream about before.
What does this mean? Well, it means we can build lighter satellites, faster, more efficient trains and cars, and maybe the most important thing, it lets us create structures with the kind of complexity and built-in strength that were just flat out impossible before. It really is a whole new philosophy for manufacturing.
So, all of this leaves us with a pretty big question, doesn't it? This technology started out holding together the fastest jets on the planet, and now it's in our cars, it's in our trains. Now that we can seamlessly bond almost any material to any other, the only real limit is our imagination. So what's next? What amazing things are we going to build now?